Welcome to Brain Vision.
Hey guys, let's do problem 94. We need to calculate the volumetric flow rate of nitrogen. We know that molar flow rate is equal to mass flow rate divided by the molar mass. The mass given here is 150 SCF. Per minute, and the molar mass is 359 SCF divided by pound mole. Therefore, the molar flow rate is 0.418 pound mole per minute. Now we can get what are the critical temperature and critical pressure for nitrogen. The critical temperature for nitrogen is 126.2 Kelvin. Let's convert it to Rankine scale. 126.2 multiplied by 1.8 Rankine gives us 227.16 Rankine, and critical pressure is 33.5 atmospheric pressure. Now let's get the reduced temperature and pressure. The given temperature is 150 degree Fahrenheit. Let's convert it to Rankine scale by adding 460. Therefore, the reduced temperature is 2.69 and the reduced pressure is 1.22. Now the Z factor at this reduced temperature and reduced pressure is 1.01. Now we can use the compressibility factor equation of its state to determine the volumetric flow rate. Therefore, PV is equal to nRT or volumetric flow rate is equal to Z nRT divided by P. Let's insert all these known values. Therefore, the volumetric flow rate is 4.61 feet cube per minute for nitrogen. Next, we need to calculate what is the minimum tank size. Now, the time required between deliveries for 2 weeks. The time is equal to 2 weeks multiplied by 7 days per week multiplied by 24 hours a day multiplied by 60 minutes per hour. Therefore, we get the time is 20,160 minutes. Now, the liquid nitrogen has a specific gravity of 0.81 and the density of water is 62.4 pound per feet cube. Therefore, the density of liquid nitrogen is 0.81 multiplied by 62.4 pound per feet cube, which gives us the density of nitrogen as 50.5. Now we can calculate the volumetric flow rate of the vapor coming from the cylinder. Therefore, the volumetric flow rate of the vapor is equal to the mass flow rate of the vapor divided by the density. The mass flow rate is 0.418 pound mole per minute multiplied by the molar mass of nitrogen, which is 20.02 pound per pound mole, divided by the density of nitrogen, 50.5 pound per feet cube. Therefore, we get 0.232 feet cube per minute, and the total volume required is the product of the volumetric flow rate and the total time. Product of the volumetric flow rate multiplied by the time, total time. Therefore, 0.232 feet cube per minute multiplied by the total time, which is 20,160 minutes, and the total volume is then 4,676 feet cube. Or it is the tank size.